Hello, gentle readers. It's February 26, 2024, Seattle, Washington. Ross Finlayson here with more about moment and motion. Last talk got to the consideration of teleological principles, that which provides for the mental reasoning apparatus the faculties of rationality and reasons why it's rational to consider how things are as they are, vis-a-vis the body of knowledge of the beliefs of things and the matters of perceived fact of things. And then for the causal, that the causality is really so much what implements determinism, that things are as from their first principles and final cause, or final cause as a final cause, as of a first principles or a first principle. So in such manner, what I hope today to do was to address some of the considerations of the thoughts of the concept of logic. Logic. It's kind of like magic, and kind of like the opposite. Logic is something that explains something. Magic is something that does not. They still have these matters of fact or perceived fact, sometimes the illusory, or sometimes just that which is a concept. Yet at the same time, though there's this entire magical and imaginary land of the abstract and all such matters of notions of contemplation, including the matters of fact that are scientific theories or can be so real in our mind, that at the same time, the real, the actual, werkelijk, or otherwise what is that which is indisputable and essentially fundamentally as it arrives at the objective, the inter-objective, that these are the kinds of things that arrive at why logic is so great for everything, because logic has all such matters of reasoning and rationality there may be. So one of the big things here that gets discussed a lot is induction, the general idea of forward inference. This is so, and it is so for the next, and there is this and the next, so it is so for this and the next, and the next, and the next, ad infinitum. Forward induction, inductive inference, that inference is the means of reasoning and the practice of reasoning, and the output is the result of reasoning, the result at these things. Then there's also the deductive inference. It must have been. It couldn't have not been. There's by the principle of elimination, nothing else it could be. Forward inference, and in a sense reverse inference, but it's as what's arrived at, generally. And so a lot of times what you'll find is that everything is built with forward inductive inference, because the idea is that causality so carries. And deductive inference yet is the great strength of all such usual matters of things of why and why not. Answering the question words, that it's arrived at, that the questions have answers, and they have distinct answers, and then they have unique answers. These are the things. And so then there's also the notion of the abduction, which is the theorizing of the sort. That duct is to flow, and so these concepts flow together in this kind of stream of consciousness, of the deliberate act of reasoning, or the conscious act of reasoning, or even the unconscious act of reasoning. That these are the sorts of things that arrive at why in the schools for formalism is the idea that logic is symbolic logic. And so abstractly, the symbols result that we can phrase concepts and notations in abstract symbols and treat them mechanically, treat them as of objects on their form in a way in which a mechanism can arrive at that their treatment is the same as the deliberate ponderance of the concepts, arrive at the same notions. So in the formalism, then, we find that the formal logic becomes that which is the very course of reasoning about things. Then, as logic is not so much a science, although there is a science of it, I mean, realistically, is we're just subjectively objective, objectively subjective creatures in the world. Even one's grasp of logic and reason is something we attain to. It's for science of it. There's as well yet that arrives at very, very strong particulars that describe how it would behave in all such matters according to the science, that there are these otherwise facts about the repeatable, observable, and falsifiable science's properties that arrive at, then we can make it so for these matters of questions of logic, why it's very rigorous, meaning we've done our diligence, we can feel that our conscientiousness is satisfied, our mathematical and logical conscience, that we're to be conscientious logicians and mathematicians. That the abstract symbolic logic then has come a long way from the senses of the symbols and the symbolry and symbology and numerals and numerology and these kinds of considerations of the mystical, the occult of these things, to then today where we've arrived at much more where the abstract symbolic logic is the greatest thing. It's usually framed in terms of propositions P and Q, that P and Q are two propositions and one or the other variously implies the other. And then the most famous rules for logic are Augustus de Morgan's rules of logic. If this, thus that. If is so, then it so follows that if not that, then not this. Because if it was this, then it would have been that. And so if not that, then it must have not been this. It's a matter of deduction, and it's a matter of reflection, it's a matter of symmetry, it's a matter of looking at it from both sides, it's a matter of modeling it as an object that carries forward this determinism usually. Where here the key thing for the logic is the determinist in logic, vis-a-vis the indeterministic and the probabilistic and the statistical in the realm of uncertainty, that there's its own thing. And as well, then we build that in terms of the determinism of the laws of large numbers and the expectations, so build the probabilistic setting. So there's always the probabilistic view of our scientific view of things. It's any one person's great experiment in life to develop their body of knowledge of matters of fact. Then the idea for the abstract symbolic mathematical logic is so how concrete it can be in so these few terms that one can relay these terms to another in only those terms, and either and both get unambiguously the same outcomes. So this is a very strong measure of the repeatability of such an experiment or a communication information. Of then the observability, either way, and then the falsifiability is that there's always this implicit tableau, a table. And the word table or tableau will come up a lot because it implies all the P's and Q's written out in terms of their consequences together and lack thereof. And what is so, what is, and by that means necessarily so, what is not so is necessarily not so, and what is not necessarily so. The weaker results has come out, which regards to then they simply demand disambiguating or explain that there's always some other explanatory factors to bring these all together and into this body of knowledge as first class in the logic. Why is so a thing? So when we think about the foundations, if you'll excuse me for a second, if we think about the foundations, then one person we might talk about in terms of logic is Gottlob Frege. So Gottlob Frege was in the time of the 19th century, the late 19th century. And so we basically describe him to be fin de siècle, but 1900. But that's the word generally around the world for the year 1900. And then fast forward 100 years, it's Y2K. Year 2000 around the world is the year 2000. Today it's 2024. Fine. So Gottlob Frege was very famous for implementing, when we talk about foundations, like the Grund, the ground, and the ground Gesetze, the idea of a ground theory, and the ground log and the Grundlage and the foundational rules, the ruleo. And so after Boole, so in the time of Augustus de Morgan, the middle of the 19th century, where there was a lot of discussion here or in descriptive differential dynamics about that in the context of David Cohen's book, Equations from God, Mathematics of the Victorian in the 19th century, about Augustus de Morgan and Mr. Boole, who was a logician, and what came of this. So, in the time of Boole, he became a great adherent of this symbolic logic, and using it to show then via the operations of arithmetic or the set associative that are natural on these objects, that they had the same meanings as with regards to considering them as logical things together, in terms of matters of category, in terms of matters of type. Usually in the logic, right above the notion of the propositions and then relations, and that's variously whether it's like, is a proposition made of relations or is a relation made of propositions? Here that it's usually always relations. It takes two things to relate to each other. Vis-a-vis a proposition is just a predicate of a relation of given statements, stipulations to true or false. That is always so. So we have then predicates are basically the application of any given answering of a question word, whether it's true or false. Fine. So we have this bivalent world of truth values. One is true, the other is false. They exhibit the quality of tertium non datur. There's no third ground. It's true or it's false exclusively, and that's the usual space of the considerations. When questions have true and false answers, it's not always that they do. It's not always that the questions, answers they relate come from the world of true and false. It's not always that the question has, as a matter of a consequence of what it evaluates as a predicate, true or false. So it's all zeros and ones in some sense. These are the binary Boolean, they're often called values of 0 and 1, or negative 1 and 1, but 0 and 1, true and false. So in a sense, 0 and 1 are the numbers, true and false are the words. In our worlds of the logical and the mathematical, for numbers and words with regards to space and geometry, with regards to algebra and symbology. Thus, in this kind of manner, it's kind of framed in the same overall thing, while at the same time also we build together the same kinds of notions for each, what we have in the middle, all the classical, how it arrives at, or Descartes' original analysis of the Euclidean, or the language of words with regards to formal languages and formal automata that begin in the finite and then fill all the dictionaries of the world, these kinds of things, out to infinity. So in and out of that, in and out of the universe of the things, the domain of discourse that it is, all that may be so constructible in these worlds, these are the kinds of concepts that get into the foundations of logic, because it's the same as the universe of mathematical objects, the universe of logical objects, a theory with these objects that are true somehow together at all. And then for the theory of all the possibly contingent but not satisfied theories of the abstract realm of contingent, and then even out to the absurd. Whereas in the numbers, you might think of the rational, then the irrational, which are still real, up to the transcendental, which are still real. Then we have notions of theories that are logical, up to that are properly logical, and thus basically separated from the logical purely, and the nonsensical. Yet still in this sense that there's a generous interplay between those things in terms of matters of interpretation for communication and matters of knowledge and for bodies of fact. So this is ranging around quite a bit, but that's because it reflects that the entire universe of mathematical and logical objects ranges over everything, including the contingent. This is that the past is written, the future is not yet written. What will be, but the future is not yet written. All right. So that's kind of what I wanted to talk about today. Was for teleological principles and what is the logical, that which is the reasonable, and how it is so that the logical, the purely logical, can arrive at, similarly as these other notions here for like after the axiomless natural deduction, for strong mathematical Platonism, that there's similarly these mathematical and logical objects that exist in a Platonic universe of ideals, that there is truth, that there is falsity, or there is truth and there's not really falsity, but there is one example of a sentence called the liar. This sentence is not true, that is at least a prototype of fallacy, everything else just being happening, that's just a consequence, one of these Sputniks of quantification, and then that it's just a prototype of a fallacy, and then everything else can resolve from this world of purely true logical objects, and then the affirmation and negation of those is the Comenius language of all the theories, truisms only, and then arrive then when we consider any contingency of any kind of statement at all in a wider world of all the classes, of all the types and categories, that it so results that there's a means of templating these to those, relating, to get to grip, to make sense of things, to think things over, and the deliberate ponderance of things, vis-a-vis evaluation and the automatic and all such things that go into matters of beliefs and goals and lack thereof and these kinds of things. So Augustus de Morgan was very much in this sense of determinism is key. And it only says what is so. And then Boole arrived at that he wanted to make very well an algebraic sort of approach in words, symbols, for what are otherwise relating those to the non-logical things, the properly logical things in their domains, to these symbols, and what's properly logical then to these yet just purely logical objects, whatever is like the fundamental type in the theory, those being the only purely logical objects, everything else being properly logical in their own domain, as of both the pure and applied, in a sense. That Boole then was using this to relate then the automatically understood operations like summation and production, or negation and difference, and these kinds of things to the terms, to relate them to types and categories that have the same sort of arithmetizations, to make a sort of symbolization of these kinds of things, otherwise the matters, the elements of the domain of discourse and communications. That this was one of the main things that Boole kind of adopted in this time, when it became that became very much so when the longer writing out of things was then made for these little languages of the symbolic. The little languages of the symbolic are formal languages. They only have a fixed alphabet and fixed lexicon. The idea being then that those being closed, then they gain the great strengths of arithmetization, later for geometrization, and for algebraization, the attachment of the behavior of these objects by their symbols to those of the theories of algebra, to the theories of arithmetic, to the theories of geometry, the theory. So Boole then put this together, and a lot of influence was received by Boole from Leibniz. And so Gottfried Leibniz was a great thinker, and he came up with some really interesting ideas in the theory. And one of his greatest ones is called the monadology So for monism is that there is a universe, we are in it. It's like this Comenius language of all the things. He examines this. Kind of like Ludwig Wittgenstein's Tractatus Logico-Philosophicus. It's got logic in the title. It's got philosophy in the title. What it entails was basically his expression of the recognition of this Platonist domain of discourse, Platonism, and then that was his establishment that is objective, and then his later works carried on into many of these different themes and the notions of the time of the existentialism, and we call that anti-Plato. We would say Wittgenstein is our anti-Plato, but here that Leibniz was kind of our extra Plato, and in a sense, kind of like Duns Scotus or Spinoza, who kind of say infinity is in, or Kant in the Sublime, as we were talking about last time, is that this is one of the key touchstones of Leibniz. And then, of course, Leibniz is also famous for that Leibniz and Newton have among them the recognition for the priority of the discovery of the infinitesimal analysis. And my favorite writer and author from around that time is MacLaurin, whose book today still reads just as well as it did hundreds of years ago. Newton was really pretty great, and Leibniz was also pretty great, and I'm a big fan of MacLaurin. So, who is a little bit after that, but very, very much so about the analysis, the inductive and deductive analysis about the symbology even being associated with these finite and infinite things that results the justification for their consideration as matters of fact. And so if there's determinism to so arrive in the infinitary. So Leibniz had this phenomenology, and another thing that Leibniz had was this idea of this universal language in this symbolism. So the idea was that it's just as mathematics is said to be a universal language, then there's the idea you can make simple little languages, the domain-specific languages of logic here, and the language of logic for the objects of logic, that such symbols then can indicate their relations in as few pencil marks as possible. That diagrammatically, then in a geometric relation, these sentences and developments and structures of the things with types and things with categories can come together in terms of one big matrix, which results this table for all these given considerations, whether they evaluate to true or false, or don't know, don't care, null, void. Maybe so. These are the kinds of things that were the goal of Leibniz's approach to this universal language. So Boole picked that up, and he kind of thought about it, and from what I understand, then he just kind of, picked a bits of it, and he said, well, I can start building up my forward inductive inference off this side of it. So I'm just going to write it like so, and this will be my approach, and nobody will be able to prove me wrong, and then that's great. Now, it doesn't admit this kind of fuller dialectic we talk about here. It's like, well, why is that not so? It's like, well, if you'd stop walking into the corner of the room, maybe you'd kind of have a different perspective on these things. Or the pons asinorum. It's a difficult bridge to cross, but somehow Zeno walks it back and forth every day. These are the matters that then arise as from Boole's consideration, how then this gets interpreted some more. So after Boole was after Comte, and so Comte was kind of also after like deism, the dogma is declining. And so in the great void that was part of what it upheld besides this entire teleological thread that comes down and goes through for all this stuff. The silver thread, here it's called, that includes this teleological and theological, or the monists' view of these things. That all gone, then because for the Comte and scientism, then needed to have at least still something to carry it forward. And so there's Comte's, Boole's, scientisms, and then into Russell's logical positivisms, what resulted in this sort of thing called classical logic. What is classical logic? Well, now we rewind to Aristotle and Parmenides and Heraclitus, but Aristotle, Plato, Socrates, and Aristotle, or Plato, Aristotle and Socrates, or Socrates, Aristotle, and Plato, that to these schools of these men are assigned all these different things about matters of logic. So Aristotle's got the syllogism. This is much more strongly detailed by De Morgan at a later date in terms of the collected considerations of it, which was all very well known. I mean, it's common sense for everybody. By a different name, it's no different. It's just that it is a very common sense that everyone has. That then classical logic is kind of these matters of syllogism. Then about the tertium non datur, the principle of the excluded middle. There's no middle ground. It's yes or no, true or false. The law of the excluded middle, PEM or LEM. Then it derives as tertium non datur, TND. So this is kind of the fundamental of the deterministic and simple enclosed. Not all things are. Not all things are by any means. Many, many simple things are, and indeed any simple thing has representation this way in terms of an Aristotelian syllogism, and which is you can write as De Morgan's rules. And then there's a great divide about the quasi-modal. So if that was so, we had a syllogism of all the objects in the mathematical universe, then that would be great, because you could kind of say that it's modal, meaning it's always in the mode. It's always all the events. It's temporal. It's like, and it's true now and in the past, and any matters of the contingent in the future are so modeled as contingent in the future. If it was temporal and modal, well, it's not, because it employs, in many cases exploits, these notions of that a contradiction arrives at then this principle of explosion, which is called ex falso quod libe, which was discussed here about in the time when there was the discussion of the De Morgan and Boole, why that's a little bit more of irrelevant in the logic, though that it has kind of this simple short circuits of like, well, if I have a false antecedent and the consequent don't matter is true, so I can just say this statement is true, even though I know it'll never be true, because who cares? It's like an imaginary guy cares. An imaginary guy cares. I'd imagine. So, ex falso quod libe, with either a false antecedent and a consequent being somehow materially implicated or materially implied and true, is not accepted here. It's called quasi-modal logic. As long as nothing ever changes and the contingencies aren't so, and nothing ever would ever turn around the clock, then that would be one thing. It's not so. It's simple to compute in some cases, and you can write direct and simple syllogisms in it unambiguously, but it's not a general purpose logic. It's not the logic, which in its orders from just the very simplest quantifiers and variables and constants as they arise, as they grow in the complexity and their contingency and their mutual contingency and their joint contingencies, then evaluating up to be the joint probabilities and these kinds of things. That's what it is. So Boole came up with that, and then it was kind of picked up by Bertrand Russell, who is a logician, and for whom is known very, very regular facts about set theory and paradoxes in logic, of which there are none, right? And the great opinion to just define an inductive set as ordinary. and say that there's infinity and it's not infinity plus one. Boole's great, or Russell's great contribution to this. So, rewinding it now. So after Boole and before Russell, there's Gottlob Frege. And so Frege was a guy, and he studied these ground rules and ground theories, foundations for logic and to work up some objects arithmetic. And he did a lot, and he came up with a bunch of it and really made it so that he's gotten a good arithmetization for his logic. It's logical, implements arithmetic. That was the idea. So then Russell came along and said, hey, Frege, this is Russell's paradox, and so I've applied it to your system, and now it's got a hole in it. And so though he has this great collection of completion results for arithmetic and logic, then Frege is just like, I give up. And it stopped being, his essays stopped getting published or whatever. And so it ended up that Russell kind of just worked up this definition and then this classical logic called comps, scientisms, Boole's, Russell's, logical positivisms, classical quasi-modal logic, which today I would just call the classical quasi-modal logic for its employment of ex falso quod lib and material implication, which I reject for relevance logic because it says that you can say anything about an unrelated term just by making a contradiction and then say that justifies something else. Saying like, well, just don't evaluate it and it's still true because someone will trip over that. And somebody up above says it's not right. So that's said. So comps, scientisms, Boole's, Russell's, logical positivisms, classical quasi-modal logic, and which is otherwise syllogisms and De Morgan and mind the P's and Q's, is keep that part. And then the other part is just an exercise in the computation of some matters and some tables of values that might be true and or false. That we want to be either true and or false in the matter of then being able to combine those with what's also called the Boolean logic, Boolean binary logic. So, Frege was pretty great. So anyways, I got a book from Frege the other day, or today, the other day, and I thought that was pretty good because after the Grundlagen and Grundgesetze, I hadn't so much heard what else he had going on, and so what he did is he kept writing for the rest of his life, and then he bequeathed all his papers to his son, and then there was started an academic project to catalog these and kind of find these issues that might still arise from them. And then most of them got burned up, and then but some happened to be left from this effort in copying, and so this is Gottlob Frege's posthumous writings. So I haven't really got too much yet into this, and what it is it's the writings of Gottlob Frege with regards to his fuller collection. And it includes some of his considerations of Boole and some of his correspondences with Russell. So I'll be getting into that a little bit. Then this other book I got the other day, and this one is called, it's about a man named Tarski. So today when we talk about true and false, then a lot of times it's just a matter of like, well, what is true? What is false? Well, what's true is that which doesn't contradict itself is not untrue. And kind of like when we were discussing about the Platonism, and then much later the ideas of truth and Aletheia, the goddess of truth from the antiquity, is that this dialetheia is the disclosing of things. That mathematics isn't invented, it's discovered. And it's been this way in the theory for all this time, the discovery of things. So Tarski truth is basically saying is like, well, within a properly logical setting, you have a properly logical definition of truth within that setting. Things line up, things add up. Things aren't not so. They're so. So Tarski has in the world of logic, then he's got a lot going on. That Goedel and Tarski then kind of come to this picture. So after Zermelo-Fraenkel set theory kind of set the floor for modern mathematics and axiomatic set theory with this ordinary, regular inductive set and an infinity that is not infinity plus one, which otherwise it would be. Then Goedel came along and built things, the arithmetizations, up in this logic over the set theory. After Russell, for example, has said, here's how I can define types in set theory, non-logically up above. And here's how I can define stratified and ramified types according to orders up in set theory, as above in this set theory. Whereas, 50 years before that or so, there's like C.S. Peirce, an American, who came up with like, this is our theory of type theory in the theory of type theory, about when the same universal mathematical and logical objects basically has to implement all these fundamental theories like set and part theory and class and particle theory and the distinctions between types and categories and their inversions, the particulars and universals, with the objects of geometry, the objects of arithmetic, the objects of algebra, each in terms of each other, each of these theories, the function theory, the topology. These being basically a gamut and a range of all the ways that they can be represented in terms of each other, all matters of relation, vis-a-vis each one its own simplest matter of relation. So that is basically the idea of what is kind of along the lines of this pure theory that's supposed to arrive at what's something along the lines of all these applied theories as a pure and applied theory. So this is logical, and this is the reasoning and rationality about it. With the goal of these completeness results, as we're talking about that Goedel established these completeness results for an arithmetic, given that it already has an infinity that's ordinary, even that might not really exist in the whole wide world of everything that is it, that it is this model and its structure of this, that is a proof theory and a model theory together, all this theory, all what the results are of it. That Goedel implemented completeness, and then there's also this great notion called incompleteness. And they said, oh, by the by, once you install that you can kind of work up out of cardinals and this other stuff, then you can find for this theorem, as I'm working in these words to come out of it, that there's another one. There are more true things about the objects of this theory than are theorems of this theory. It's incomplete. There's a wider theory that is more complete. And it's still true. It must be non-contradictory. Everything kind of just is in terms of itself. So Goedel has these great things about the completeness and incompleteness. And Tarski makes it just so, hey, as long as this is so wide open and we don't really have necessarily these notions of what's true, here is a working definition of practically what's truth is. And so then you can say it's just kind of within this particular domain, it's that which is a theorem, according to this model, which you can't otherwise find any flaw with. After that, it has to go through the ringer and come out the wash, and vice versa, and has to be evaluated all the different ways. Thoroughly relevant in all matters of inductive and deductive aspect, and when they must promise together to not compromise this sort of to be able to say that it can be decided, the judgment of this thing's truth. So to Tarski is associated this notion of Tarski truth, which is local in this sense. It's particular to the domain of in this discourse. So this book, and I haven't read it yet, but I just got it. It's a biography of Tarski, and it's by the Fefermans. So Solomon Feferman was a great American logician of the 20th century and into the 21st. And he addresses some of these things like the outside the ordinary, the extraordinary. It's called various things. It's called the non-standard, because the standard is Archimedean and then it's ordinary, and so this is if it's non-Archimedean, it's also non-standard. Or the non-classical is like, well, when classical logic is really classical quasi-modal logic and our real logic does not always agree, or it agrees that there are some things that classical quasi-modal logic does not say. They call that non-classical logic, but really what it means, and it can still be, is classical, not necessarily quasi-modal logic. Schools like relevance logic and these kinds of things. The logic, yeah. That Feferman brings up a bunch of interesting questions about the impredicativity, quantifier ambiguity, and quantifier disambiguation, when this for any, for each, for every, for all is a richer and more necessary deliberation than the universal quantifier, that it reflects when things are as about themselves, all gesammelt or collected. That then it appears that Solomon Feferman and his wife wrote this biography of Tarski because they were acquaintances and friends for about 30, 40 years. They lived in the same world and in the same surrounds and knew each other. So it just says he's one of the greatest logicians of all time. He's widely thought of as the man who defined truth. This is a biography, and it describes, model theory in the 1963 symposium. So model theory is very telling and important because basically our proof theory is a model theory, and our model theory is a proof theory, and they model improve each other in terms of what is in the theory of these mathematical objects. So there's a chapter here. It says, interlude 5, model theory in the 1963 symposium. The word model, in its usual scientific sense, is quite different from the sense in which it is used in logic. For example, a Newtonian model of the physics of moving bodies employs the constants of mass and force, ... So that is what we'd call the physical model. When we attach it to the mathematical model, it does result that mathematical model is one of these logical models. It's a structure of these objects for which we have symbols, and they're all related formally. That's the way it is. DNA, scientific models, cosmological models, scientific models. For the logician, models are the realization of axiom systems or bodies of structure relation or other bodies of models that are given by interpreting their basic notions in one way or the other. We call this comprehension. And there's basically either expansion of comprehension, then that sometimes an axiom like Russell's there is an ordinary inductive set is a restriction of comprehension, because it's like, well, infinity equals infinity plus 1. He's like, well, no, it's restriction of comprehension. So that's what we call this a realization of interpreting their basic notions. Ordering relation, it describes some properties that hold among relations, their relations in relations, transitivity, associativity, asymmetry, comparability. The real numbers also form a model of this statement of density. So we talk about trichotomy and in topology and function theory, then these notions that arrive for the structures of these things that are the continuous and the dense and the continuous and such. Geometry, more interesting models. Geometry, infinity, Euclidean geometry, non-Euclidean geometry. So this non-classical logics and this non-standard logics are as well this sort super standard, super classical logics. And again, this sort of reflects on a couple different things. One is the extraordinary, the infinity is sublime, according to comprehension. And that the numbers are regular according to Zeno. Those being just standard, super standard. And then that the non-standard is also stuff is like, well, also it would carry out that some of these things have what would result stronger laws for them and weaker laws for this stuff. So it's just a matter of relativity that's like, well, what's non-standard here is standard there and vice versa. Vis-a-vis the extraordinary and the non-standard of a mathematical infinity, and then this non-classical of logic, which is really just a rejection usually of the classical quasi-modal logic. Still all quite classical and paleoclassical and classical again. And he goes on to say, the Fefermans, the general definition that logicians give for the notion of model is rather technical. What follows here is a fairly non-technical explanation. Required at the outset is a formal language, L, that has one or more basic kinds of variables intended to arrange with the different kinds of objects in interpretation. We have some constant symbols of specified kinds and some operation symbols for building terms of various kinds from various constants. For example, this Comenius language is like, it's really rather trivial. True. Finally, L is required to have one or more relation symbols to express relations between terms of specified kinds, usually including the equality relations. Here we talk about intentionality and extensionality and tautology and sameness and difference and the relations of types and everywhere and almost everywhere. And for example, that equality would generally be considered a first order relation, and in some theories it's variously a higher order relation because these structures we intend to relate aren't really otherwise relatable on their own structures, but must be in some higher structure. All this kind of stuff. Finally, L is required to have one or more relation symbols to express relations between terms of specified kinds, usually including the equality relations for each such. By an interpretation of L is meant a structure consisting of a domain of objects for each basic kind of variable, as well as an interpretation of the relation, operation, and constant symbols of L by actual relations between, operations on, and members of the domain of objects of the appropriate kind. Equality relation symbols are interpreted to be the corresponding identity relations. We have singularity and multiplicity theory. We have theory about all these things in their abstraction. It's kind of the way it is. And then he gives some examples of plane geometry. And so the idea that that's kind of a not very formal definition of what a model is that's a very formal definition of what a model is. It's in terms of the forms, in the form of natural language, which necessarily implies sort of a generous reading to let it rid itself of its baggage, and that it still must then carry its own weight through. But then in terms of that, otherwise just being in terms of symbolic values with the operations defined on them as so reduced or refined to a calculus of reasoning, or the rationatur, that this is a very good definition of what a model is. The well-formed formulas of L are generated from what are atomic formulas, which express relations between terms of appropriate kinds by closing under various logical operations such as negation, conjunction, universal quantification, and so on. For example, affirmation and negation. The logical operations chosen constitute part of the specification of L. By a sentence of L is meant a formula without free variables. By an axiom system in L is meant a set of sentences of L. So in this sense, you can kind of see again how this Comenius language fills this role of truth from the bottom, from the ground. It's the ground, Grundvora kind of a thing, the ground truth, the ground laws of the ground system. Foundations, then that all these other different theories of universes and domains of discourse of logical objects are way up in that, in this meta mixture of model theory and proof theory. The basic relation between a sentence S of a formal language and a structure M that interprets L is that of S being true in M. The applicable concept of a truth here is that of truth in a structure described toward the end of interlude 3 as a modification of Tarski's definition of truth in his famous Wahrheitsbegriff, Truthhood essay, paper of 1935. Structure is said to be a model of an axiom system. Of each of his axioms is true in the structure. That there's, when you say in model theory, you say that everything witnesses all the other true statements. And so a faithful model has no contradictions. It has nothing that contradicts each other, either directly or circuitously. So that's, the models are generally described in terms of that the property of a model is being faithful, but really there's a general idea that models that aren't faithful are to their own truths are not really models at all. They are a different kind of structure that does not fulfill these definitions. So models are structuralists and constructivist truisms vis-a-vis that which are not models, and then in the relation of the consideration of things that do or don't agree, that then it gets involved. It's like, well, these are models in their respective theories with regards to then whether the models do or don't agree or the theories do or don't agree. Or that neither could ever agree because there's really an underlying theory in its comprehension which contains them. Or they're nonsensical. Or these kinds of things. So that is a pretty nice little thing to find here in this biography of Tarski. And then it includes this. It is unfortunate common terminology in logic these days to use the word theory for an axiom system, so that one speaks of models of theories. The primary examples of structures dealt with in model theory come from mathematics. In that respect, model theory is a part of metamathematics, and it is an informal mathematical theory whose subject matter is formal theories and their models. See here, it's for structuralists, it's the formal theory. So I don't really know about that. He said, and the Fefermans continue a bit, and they say, Tarski and model theory. Tarski did not create this field, but as Robert Vaught later wrote in a survey of it for the occasion of his 70th birthday celebration, his influence was decisive. Tarski laid the conceptual foundations of this subject, Lowenheim-Skolem theorem. So the notions of models are around already. Jerzy Luz. Tarski's articles in the mid-50s, Contributions to the Theory of Models. Other contributions to model theory being made at the time by Tarski students Chang, Feferman, Montague, and Vaught. Independently of the Berkeley School. And then it says, in that same year, Tarski, together with Dana Scott, took a significant step in the enlargement of the subject by permitting the operations of conjunction and disjunction to be applicable to infinitely many sequences at a time. Sentences at a time. So this gets into the infinitary. And again, this is a particular formal system, not necessarily the formal system. Here the idea is to figure out whatever we arrive at, it's from the one that already is there. We do not invent logic, only discover it. And get it formalized and get it in an agreeable form, and then so simply they can be shared. So he says, infinitary model theory is the title of this section. And then we talk about what is the infinitary and the pairwise, like this forward inductive inference, and the infinitary and the illative, which kind of brings it all together, like the infinite union vis-a-vis each of the pairwise unions as a course of forward induction. Two different things. Indeed, modern mathematics ZF set theory does not include infinite union, only pairwise. The theory really does include it. The idea is like, yes, it's turtles all the way down, or yes, 0-1 is broken all the way out, is a complementary concept in these two models that then eventually agree and meet in part, each on their own parts, these ways. So yeah, when it's a little brighter, which will be just a little bit earlier in the afternoon or evening, I'll read a little bit more of this. And this is a great book. I'm looking forward to reading this. I'll be planning on using this to help me very well establish what is the goings on and surrounds of all of 20th century's logic from the main schools, vis-a-vis these writings from Frege, the further works of Frege, which I plan to observe in these very particular insights that are kind of the other side of this coin, because it's Frege trying to dig his way out in a sense. So that'll be exciting. I'll comment about this some more later. So we've been talking about logic. Now here is another 20th and 21st century logician, is by the name of Badiou. So kind of like earlier I said, yeah, Newton had more going on maybe than I give him credit for, even though I still think that he was a little high on the shoulders of the giants that he didn't credit very well. Besides standing on the shoulders of all these giants, he's like, and I also trod underfoot a bunch of other people, and I think MacLaurin is really great, and it reads as well today as if it were written 5 or 10 years ago. That is the most modern sounding of these books. The style is in MacLaurin. Badiou, the other day I was studying him, and he's like, well, what are his notions of truth? And he kind of has this, well, there's logical truth, poetical truth, truth to beauty, and another kind of truth. I was like, well, that's not one. How's that going to work out? But so from reading Being an Event, it's still kind of like, well, that's not the foundations we have either, but it's still pretty great. So I got this other book, and it's after Being an Event is this Logics of Worlds. And so it helps explain kind of like when things get relative, vis-a-vis like in a foundations, there is the theory, there is the a theory, the definite article is then for this kind of work to follow on that he's helping define and refine the notion of truth for our teleological principles. All right, then. So that's kind of the story today, following on in this theories, and what was discussed was the idea of theory, and then there's a universe of logical objects, and then we have our practical logic and matters of belief and non-contradiction. Then there was discussed the induction and its great strength and its weakness. It's kind of like in the old days, everything was horse-drawn. And to keep the horse has got eyes on the side of its head. It's got like very, very wide-angle vision, which the idea being to prevent it from getting predators, or something like that. So anyways, they put the blinders on the horse so it would exactly go forward, and it could only see what was in front of it. So inductive inference has nothing at all to guarantee that it ever leaves its course, unless it does, in which case it does. And it has nothing at all to guarantee it is only potential, unless it's actual, in which case it is. So that's that was one of the notions here today. And one was that of truth, and then the completion in the truth, and the logical and the properly logical, and the properly logical and the non-logical and the absurd, and the nonsense. Were related together as a part, and the notions of propositions and predicates and relations and so primary and fundamental and this universe of mathematical objects and this domain of discourse. Then the theories of categories and types and their classes and their orders, and the ordinary and the extraordinary, and the standard and the non-standard and the superstandard, and the classical and the classical yet only quasi-modal, and the non-classical or the classical modal logic. And that these are the kinds of things we talked about today in terms of then the teleological principles for reason and rationality and the rationatur. That gets back to basically Leibniz as just like, it must be this kind of way. This is the usual kind of approach for somebody who's trying to put it all in one box, as it were, and with a way out, for the great gift of Goedel that he says, well, I have a complete arithmetization in my theory with Russell's infinity, also there's more. And for Tarski's, great inner concept, he's like, hey, it's true as long as it doesn't contradict itself. It's not untrue. If that's what you need as a definition altogether, whether, because when you get into the necessarily not and not necessarily, otherwise all that's got to come out, and all that can come out is true. That then this helps give a brief recapitulation of the state of the study of the symbolic logic and the mathematical logic since the 1900s, the fin de siècle, the 20th century, Y2K, and on to today. So, good day, gentle readers, and I shall so hope that this brief foray in the lessons of logic and the learnings of the logic is its own kind of magic that anybody can do. Hey, all right. So long.